Hello. In this video, we're going to do a couple of derivations that involve our new rule addition with the disjunction. So, very simple argument, r, therefore r or t. So, we'll start off with showing the conclusion. There's no assumption to be made because we are not trying to show a conditional. So, we'll just put in our first premise, and that's all the premises that there are, and now we need to get r or t. Well, addition says if you have r, you can have r or blah, or blah or r for any blah you want, and the blah we want is t. So let's say, let's add to r. So this z, it's red here, and that means we get to choose whatever we want. And it's t that we want. But where do we want the t? We want it here on the right-hand side of the r. So we're going to pick this second option, say OK. And now we're asked, well, what do you want to put in for z? And what we want to put in for z is t. And there we go. Just to show you what's happening with that rule a little bit more. So we can put whatever we want over there. So we could say not p or q, I suppose. And there it is. We have r or not p or q. So we can put whatever we like on this side of the disjunction. But sorry about that. My computer's acting slightly funny. That's not anything happening with you. So we have r or t on line 3, and that's the conclusion, and so we will go ahead and say direct derivation. And we'll check it, and it's all fine. Okay, so let's look at one or two more. Okay, so here we have, that's kind of annoying. I'm not sure why this is happening. But, okay, here we have p and q is our first premise. Second premise is if q or r, then s, and our conclusion is s. So, no assumption. Premise 1, premise 2, there is no premise 3. Okay, so we want to get s. And if we look at what we have p and q. So we could go ahead and split up the and on line 2. So now we have p, and separately we have q. Good, we've taken care of line 2. But we're looking for s, and we notice that line 3 is a conditional whose consequent is s. And so if we can get the antecedent of line 3, then we'll be able to do modus ponens, and we'll get s, which is the conclusion of our derivation, and we'll be done. So the antecedent of line 3 is q or r. So what we want is q or r. So if we had r, we could do addition, and we would put q on the left. We don't have r. But we do have q, and given that we have q, we can apply addition, and we can put r on the right. So we'll say 5, and we're going to add r on the right. So we're going to say, what do I want? So here it's add r, that means right, so it means on the right of q, add something. So I only have to go through one box. And what do I want to put in for z? I want to put in r. And lo and behold, that's the antecedent of line 3. So I'll do modus ponens. And look, that's the conclusion, and so we can say direct derivation, and we're good to go. So let's look at just one more problem. So here we have, if p or q then r, therefore, if p then r. So we'll show our conclusion. Now this time we're trying to show a conditional, and so we can make a conditional assumption. And since we're trying to show a conditional, what we want to think is, well, we probably want to get to r, and then we can box and cancel with cd. Maybe we'll get the whole conditional, but if we get r, we're also good to go. So there's premise 1, there's no premise 2. So we look at line 3, we say, oh, aha, that's a conditional. Its consequent is r, so it would be nice to get that. And if we could get the antecedent, which is p or q, then we could apply modus ponens. Well, we can get the antecedent again using our rule r. So we'll say to add, and we want to add q over here, so we're going to select this option, and we're going to say we want to put in q for z, and there's p or q. So then we will say 3 for modus ponens, and we get r, and that is the consequent of the conditional we're trying to show, and that means we can box and cancel with cd. And there we go. We're good to go. So those are some examples using addition. The main thing with addition is you have to understand how to go through those windows, and you also need to recognize how flexible it is in a way. You know, if this was p and q, you would need to have both p and q, but it's p or q, and so we have p, and that means we can get p or q with addition, because we can put whatever we want over there. So the main thing to remember with or is how flexible it is, that you can put whatever you want on either side. And just to also make something clear, we could have put the q on the left if we had wanted to, by choosing the z on the left. There's no reason to do this in this derivation, but it's entirely correct. It's entirely valid reasoning. It just doesn't get us anywhere we'd be interested in going. So, there's some derivations. If you have any questions, please let me know. Good luck deriving.